Good morning, my dear students. So, in this session, we will be discussing on supercharger and turbocharger. So, this is an important topic which comes in the third module. The objectives of this session is to one, what is the requirement of a supercharger or a turbocharger? That means what is the need of this in an engine, why we are employing this in an engine. That is our first objective. Then we will discuss the types of supercharger, different types we are using in commercial vehicles. The working of supercharger also we will discuss. Then we will have the advantage and disadvantage of supercharger. Working of turbocharger and what is the difference between this supercharger and turbocharger, that also we will discuss. And finally, the application where this applied in a commercial vehicles. So these are the objectives of this session. Going to this supercharger, try to answer this question: what are the objectives of an engineer designing an engine? What are the major objectives of any engineer working with engine? Please answer this question. So hope you have some answer in your mind. So mainly we have two objectives. First one is to maximize the power output, that is to obtain the maximum power from an engine. That is our major goal. And second one is to minimize the exhaust emissions, because each country we have certain emission norms. You have to satisfy that, then only you can use it commercially. So these two are the major objectives coming with an engine. Now this is our next question: what are the factors affecting the power output? So we want to increase the power or maximize the power. What are the factors, or how you are going to increase the power? Answer the equation. You have already seen this equation. That is, brake power is equal to pressure into Vs is swept volume, N is the number of cylinders, and capital N is the RPM of the engine. So that means we have four factors. The first factor is the mean effective pressure. Second one is the swept volume, which is nothing but the area of the cylinder into stroke length. And the third one is the number of cylinders. And finally, we have the speed of the engine. You have an engine already, you have fabricated an engine, or already you are using an engine. So how we are going to increase the power? That is our next question. So already you have a fabricated engine with you. So you want to increase the power. So that means you don't have the freedom to increase these 2 and 3, the factors, that is swept volume. You cannot increase because already it is fixed. You cannot increase the swept volume. The number of cylinders also you cannot increase. Then only two remaining things are: number one, either you can increase the mean effective pressure, or you can increase the speed of the engine. But if you increase the speed of the engine beyond certain limits, the frictional power also will increase and the net power will be less than predicted. So that the frictional power will be subtracted from indicated power to obtain the brake power. So the speed cannot be increased beyond certain limits. So the only factor remaining is to increase the mean effective pressure. So that is the most preferred method for increasing the power output. That is by increasing the mean effective pressure, the first factor. So now just recollect what is the mean effective pressure is. So this figure, first figure is an Otto cycle. So mean effective pressure is the hypothetical constant average pressure that will give the same power or same work done in one cycle. So we are replacing the Otto cycle or whatever cycle by an imaginary cycle with a rectangular cycle, and this pressure, the height of this rectangle will be mean effective pressure. So these things we have already studied. So the shaded area represents work because this is a PV diagram. The area under PV diagram is work. So this area is same as this area, and this height of this second figure will represent mean effective pressure. Now how we are going to increase the mean effective pressure? That is the next question. So one simple method is just increase the pressure at 1 or just increase this pressure level. So simply you can increase the mean effective pressure by increasing this pressure, the first pressure or pressure at 1 or the pressure of the air in the suction stroke. So normally that pressure will be around atmospheric pressure, but in this case if you want to increase the mean effective pressure, you have to increase the suction pressure. So that is mean effective pressure can be increased by supplying an air at a pressure higher than the atmospheric pressure. So our next question is how we are going to increase this pressure greater than atmospheric pressure. Simply you can apply a compressor. So that is the supercharger. So supercharger means simply we are applying a compressor external to the engine so that it can supply air at a higher pressure than atmospheric pressure. And as pressure increases, you know the density will increase, the mass of charge will be more, and more oxygen molecules will be available because air contains 21% oxygen, and if you are increasing the pressure of air, more oxygen molecules will be available inside the engine, and it will help for a smoother combustion. So what is supercharger? The device which used for increasing this supply air pressure, we call it as a supercharger. So charge means normally we are calling the air fuel mixture or the air which is going to the suction stroke is called as the charge. So supercharger means we are simply increasing the pressure beyond this atmospheric pressure. Now the types of supercharger, we have 3 types. First one is a centrifugal type. Similar to a centrifugal pump, you can see the main components are a rotor, around the rotor, then finally a spiral or volute casing whose area is increasing gradually. Air will be going axially or the inlet will be axially and it will go out radially. So like here in this arrow represents the direction of air. And second one we have a vane type compressor, which is an axial flow compressor. You can see the inlet is axial as well as outlet is axial. And third one is a roots blower or a roots type compressor. Here we have 2 rotors, one horizontal, one vertical, and they will be rotating continuously and the air will be passed through the space between these. So this is a displacement type compressor. So these are the major 3 types we are using for supercharger. So mainly we are using in major vehicles, we will be using this centrifugal type, and we are also using the vane type and the roots type compressor. axial means vane type, on displacement means the roots type compressor. So these are the types of superchargers. And this is another important point, that when you are applying a supercharger, you are not changing the size of the engine, but and you are getting high power. That means you can emission or you can reduce the exhaust because you are not changing the size of the engine. So you are not altering the engine for getting high power, but at the same way you are getting more power without changing the size. So that is this point. The other question is how you will get the power for this supercharger, because any compressor requires a work input or power is required for rotating this rotor, etc. So that power is taken from normally the crankshaft itself. Supercharger will be driven by the crankshaft itself, either by a gear arrangement or by a belt drive. We will be extracting power from the engine itself. So the engine power will be somewhat reduced, but if you take the net effect, the power will be more. So that is an important point. All these type of supercharger requires some amount of energy which is derived from the engine itself. But if you compare the net power of a supercharged engine and without supercharged engine, the supercharged engine will have more power. This is the layout of supercharger. This you have to draw in the examination. So working of supercharger is asked. So you can see the first one, this is the compressor. This one represents a compressor. The shaft of the compressor is connected to the crankshaft of the engine through this gear arrangements. So this is the compressor, this is the gear drive, and this is the engine shaft. So the air is coming to the compressor increase the pressure and temperature. As you know, the pressure increases, temperature also will increase. So you have to reduce this temperature before going to the engine. The air temperature should be reduced, which is done by this after cooler. So we are applying a small heat exchanger or after cooler for cooling the air. Then it will go to the engine. So you can see here the exhaust here is simply ejected to the atmosphere. No role of exhaust in this supercharger. So once again, this is the air coming to the compressor. Compressor increases its pressure and temperature, density, etc. And it is cooled in the aftercooler and given to the engine. The exhaust is rejected. And the compressor shaft is connected to the engine shaft through some transmission system. Here we are using a gear drive. So this is the layout of supercharger. You have to study this and draw neatly. Now what are the effects of supercharger, or what are the advantages and disadvantages? So first advantage already we have discussed. It increases the high power output we are getting. Then another advantage is in diesel engine, CI engine. CI we know it is compression ignition. Diesel engine, it results in better atomization of fuel. So diesel engine, you know that fuel is injected in the fuel injector. So high pressure of air will help for better atomization. And similarly, the better mixing of fuel and air in diesel engine. So that is another advantage. Better mixing of fuel and air takes place. And another important advantage is the acceleration, the maximum speed we can achieve quickly, or quicker acceleration. A supercharged vehicle, when you compare to a non-supercharged vehicle, it will have quicker acceleration. The acceleration will be high. So that is important advantage. So that is why we are applying it in the racing vehicles. That we will see in the applications. And And this one also we have discussed, because of more oxygen molecules and more density, the combustion will be complete and smooth. And another advantage is cold starting. You know what is cold starting? When a vehicle is idle for a long period, it will face difficulty in starting. So that is known as cold starting. But a supercharged vehicle will have lesser cold starting problem due to this high pressure. The reduced exhaust, because we are getting more power without changing the size, and we are also having a better combustion. It will help in reducing the exhaust. So these are the major advantages of employing a supercharging in an engine. Now let us see what are the disadvantages. So first one is the pressure. You know supercharger is using a high pressure. So the engine must withstand this high force due to the increased pressure and gas loading. So the engine must be more strengthened. The materials used for engine should be strengthened than the non-supercharged engine. That is another disadvantage. Then another one, as you know, the temperature of supercharged engine will be more due to the high pressure and better combustion. So it will be having more thermal stress. Thermal stress will be more. So the piston crown, piston ring, valve seat, etc. must be made of a better material which can withstand this thermal stress. So that is another limitation. The material of these components should be able to withstand the thermal stress. Then this is another important limitation, because in SI engines or in petrol engine, this increasing pressure and temperature will lead to detonation. So detonation or knocking is an abnormal combustion that we will study in the next module. So it is very harmful to the engine. But in petrol engine only, this increased pressure and temperature will increase the chance of knocking. Diesel engine, this is the reverse. In diesel engine, if you increase the pressure and temperature of the cycle, it will reduce knocking. So in diesel engine, we can apply supercharger without any doubt. But in petrol engine, you should be very careful. If you are that limit of increased pressure and temperature, it will lead to detonation, which is very harmful. See what is a turbocharger is. So this is a block diagram or layout of a turbocharger. Just identify the difference of the previous figure. So you can see here the compressor is there, the engine is there, but there is no connection between the compressor shaft and engine shaft. Then how the compressor is running? With the help of a turbine. That is why it is known as a turbocharger. So you can see the working of a turbocharger here. The exhaust is going, not wasted to the atmosphere, but it is going to the turbine, a gas turbine. So you are utilizing the energy of the exhaust, the pressure and kinetic energy, to rotate a turbine, and that turbine shaft is connected to the compressor. So it will run the compressor, and other things are same. So the air is entering through here, compressor inlet. Compressor increases the pressure, temperature also increases. We are applying an aftercooler, and it will go to the engine after that. And the exhaust will go to the turbine, produce some work, and it goes out. So that is the difference. In turbocharger, the supercharger is driven by a gas turbine which uses the energy of the exhaust gas. And there is no connection or no mechanical linkage between the engine and the supercharger. In turbocharger, one limitation is compared to supercharger is a turbo lag. So what is a turbo lag? So while you are starting the engine, after some time only the exhaust will get sufficient energy to rotate the turbine. So this time gap, this short time between starting and the development of sufficient exhaust to rotate the turbine is known as turbo lag. So it will be different for different engines. So it is a main limitation compared to supercharger. Turbocharger assembly, you can see this is a compressor, centrifugal compressor, centrifugal turbine, and a turbo shaft, compressor housing, turbine housing. So the air is going actually in and going radially out. So you can see the direction of these are opposite. In compressor, the air is going axially at the inlet and leaves radially, this blue line, blue arrow. And in turbine, it is the opposite. The gas goes radially in and it leaves axially out. So the parts of a turbocharger are a turbine wheel, a turbine housing, turbo shaft, compressor wheel, compressor housing, and bearings. And here we are using a control unit known as valve, a control unit known as waste gate. So mainly in petrol engine, in SI engine, we have already discussed we have to limit the maximum pressure to prevent detonation, and that is done by this waste gate arrangement. So in SI engine, we will be using a waste gate also for controlling the air pressure, because the exhaust, as the exhaust pressure increases, turbine will produce more power, the compressor will get more power, and the pressure will be more. So you have to control this. For that, you are using a waste gate. Finally, we have come to the application where this supercharger or turbocharger is used. So mainly we are using in racing vehicles because of quicker acceleration, more power. You have to employ a supercharger or turbocharger in racing cars. Then in marine engines where the weight and size has to be reduced and you can get more power with smaller engines, you are using it in marine vehicles. Then engine working at high altitudes, you know, as the altitude increases, for example in mountain vehicles, hill climbing vehicles, all of these altitudes, the air density will be less compared to sea level and the engine will face difficulty in working. So in such case, we can apply the supercharger or turbocharger for better performance. And almost all the heavy vehicles, especially diesel vehicles, we can apply this supercharger and turbocharger. So this, we are concluding our session. Thank you.